meters away from the monitors thing that you can mirror the displays.
It must be.
Okay. Do you want to try it or just want to go this way?
I'll go this way.
Quick announcements. There are a number of lost items that are in registration. If you have lost something like a phone or keys or glasses, check there. All right. There are a number of lost items in registration. If you've lost something or know someone who has, there's a phone. Check in registration. We will be tearing this room down and mixing it with the other one as soon as this is over, so if you can reasonably quickly move out of the way of people rearranging the room, that would be nice. And I would thus like to introduce Blake Hartstein, who's talking about JSunPack, which is an unpacker for JavaScript.
Hi, everyone. So this is my first Shmoocon, and we had a lot of fun last night at Close, and I want to tell a story about on getting on the metro. We had the three of us, and we were rushing onto the metro, and apparently the metro doors close very quickly, and they won't allow you to open them, and they don't work like an elevator door. So one of our friends got left behind, and we were just laughing at him. But so I'm talking about JSunPack today, and there's a couple things I want you to get out of this talk. Mainly, it's that you can automatically use engines to decode the JavaScript that you see in a lot of these exploit kits and that get placed on websites all the time. The other thing that I think you guys will get out of this is the ability to encode your JavaScript in a way that it's difficult to decode. It's a really difficult problem to solve. So basically, we all know there's a bunch of exploits out there, and that when these SQL injection attacks occur, when all these other exploits end up on the system, they're hidden in sometimes 5 and 6 levels of obfuscation. So it's a really, the goal of this is to automatically decode these because they're so difficult to do manually, and they're really time consuming. I'm going to talk about JSunPack so you could design something similar to this, and also understand what choices I've made along the way. And finally, some advantages of my choices and disadvantages. And then finally, where I think JavaScript threats are going in the future. So the problem here is we see a lot of malware authors that are actually spreading banking Trojans, stealing gaming credentials, and doing all sorts of malicious behavior, and injecting these executables onto sites. And it's very time consuming. Attackers have a lot of automated tools to do these things, and the basic way that they hide the code are one of these functions. And you basically take a string, translate it, and then translate it again in the reverse, and then pass it to one of these functions, and then you have no idea what it would be doing. So the primary reason that you would want to do that is because the intrusion detection systems are all looking for these things to track the ongoing threats. And if you do this, it's very hard to actually detect any of these things. And a lot of the rules depend upon these functions, but you don't necessarily have to actually mention the function in your exploit. So I'll be describing ways to do that. And I think the reason that this is happening and that they're evolving so quickly is because the commercial applications of it and these toolkits are being sold for hundreds of thousands of dollars. The other thing that we're going to talk about is detecting researchers and preventing them from doing the analysis. So to understand the exploits that they're injecting into pages. And then finally, JSunPack tries to solve this by creating a database of historical threats around JavaScript exploits and keeping that for a reference. So I'm going to go into some previous solutions here. And basically, this is how you would understand JavaScript if you were doing it manually. You would download the JavaScript, modify the code in some way, and then open it in an actual browser. And you could put a text area or write it to a file using the file scripting object, and then replacing large segments of the code. And you can also take the translation functions and directly decode those, but this is not a very elegant way of doing it, and this is the technique I used before JSunPack. Now, you could also attach a debugger and look at the errors and inspect variables that way. So attackers actually output end text area fields. They use the arguments.callee function, which returns the current contents of the function, and they use that as an encryption key when they hide the contents. So if you modify any of the functions that they're using that on, then you won't get the correct decoding. The other issue with this is the environment variables. If you save a file to your local system, then you change the URL, you change a lot of the other environment that they actually look for these types of things and use them as encryption keys. Finally, version detection. One of the things that we do when we analyze malicious code is we test it with multiple versions, but that's not feasible because you have to test every permutation of browsers, browser plugins, all these different things to understand and reliably detect if an exploit is occurring. So finally, the timing issues. If the server-side code is looking for a request within a couple seconds of the initial request, then manual decoding is going to fail very easily. And also, a lot of these exploit kits only allow you to fetch the file once. And looking at this manual method is prone to failure because of that. So a more elegant solution is to actually hook JavaScript. And this eval is being hooked here. We're assigning the previous eval to my eval and reassigning that function to print the string and then eval the function. So Dave Zimmer released a tool in 2006 called JSDecode, and it actually runs the code within your browser and does similar types of hooks like this. And basically, this is a very quick and adaptable way to do it, but you can defeat it. And in this case, with Func1, we defeat JavaScript hooks because of scoping problems. So the ABC variable there is defined to an array, and that print ABC actually gets evaluated in our newly hooked function. So previously, it would be evaluated in the Func1. So to defeat this, we would have to actually inject into the source code of the JavaScript engine. Dieter Stevens has a modified version of SpiderMonkey, which does exactly this. And this is an example of running SpiderMonkey with various JavaScript files. Stefan Chenette also did some work on injection technique into the Windows operating system, where you actually visit the website and then it would hook the JavaScript eval functions directly in those libraries. So this doesn't require any modification, but it does require an infected machine. So no talk would be complete without Mozilla. And we'll get to JSunPack in a minute. Bobby has designed a lot of great things like a shellcode emulator on here, which I'd like to add to JSunPack. And HTML processing and that. So my major goals in JSunPack are to make it safe, to make it so that you don't need an infected machine, because a lot of these prior solutions actually require you to run a virtual machine or actually infect yourself. So if you want to analyze multiple files, you might have to revert the machine or actually take a lot of time doing that. Also, to create an archive of all these historical cases, simulate the browser as reliably as possible. So actually simulating all the plugins, the Flash and PDFs. And I want to combine all the best hooking techniques here. And in some cases, JavaScript hooking is the best solution because it's very quick. And we don't need to have the source code of the JavaScript engine to do that. And the other problem is if a company has had an infected machine visit a website and it actually, the researcher might need to use a proxy to access it again because of IP blocking. So JSunPack can serve as a temporary proxy for them. And finally, to integrate with intrusion detection and to use crawling to find new JavaScript files and automatically decode them and understand really what exploits people are using and if they're using 0 days or new exploits out there. So I want it to be fully automatic and require no user interaction at all. Whoops. No, it's showing up on my screen, sorry. So basically, I want JSunPack to be fully automatic and not require any types of decoding. So like a lot of these tools use base64 decoding and all those other types of RSA decoding, and all these exploits use various different types of encoding, but that's not a long-term solution to this problem. And we got a wombat. All right, so this is JSunPack's design. It's mostly written in Python. And it acts like a browser, and it follows iframes and embedded objects and looks for JavaScript. One of the problems with doing this is that the HTML actually contains a lot of content that the JavaScript itself accesses. So all of these get element by ID, inner HTML, those functions are JavaScript functions where the HTML content affects the JavaScript code. So additionally, a lot of exploits will embed additional code, like a create element, and append it onto the end of an HTML page. So a lot of these dynamic requests using the XML HTTP library and like AJAX type requests can be accessed through JavaScript. And then we have the environment variables written in mainly JavaScript and a lot of the hooking functions that I talked about, and simulating the ActiveX plugins and other plugins. So here's an example of an encoded JavaScript where the eval function is being assigned to a variable. And you can see how this would be very difficult to detect because you could hide the contents of the eval and assign that to a variable, and then you would never see that function call. So this is a PDF exploit. When you run it through JSunPack, you see the actual payload because of that hook function. So this is a demo of a sample JavaScript file, and basically it loads a PDF file, and so here's JSunPack in action. You just supply a URL or JavaScript here, and then it'll fetch this URL and show you the contents of the encoded page right here. And here we can see the ActiveX being initiated, and we see the inner HTML functions being called. So that accesses the HTML and replaces these characters. And JSunPack follows that, and the hooked function outputs this content, which contains various exploits and the shellcode here. And it also embeds the PDF so it embeds a PDF file, and then we fetch these additional files, and we decode the PDF file, and we find another eval function, which was the example from earlier. And then we see the PDF exploit after decoding the PDF's JavaScript. And here we see a util printf exploit and a collab.collectEmailInfo exploit. And finally, it actually finds several executables associated with this code. So we're basically taking all of the decoded content and looking for these iframe scripts embeds, also redirects. There's also a variety of different techniques that they use. Flash redirects are a common one. So we decode Flash files and look for those URLs. And basically it's a very easy analysis tool. It doesn't require any understanding of the techniques that I discussed earlier, and basically anyone can use it automatically. with the executables that it identifies, it uses ClamAV and the leave temps option, which unpacks statically a lot of packers. And then we look for certain strings, file names, registry keys, and other strings of interest. And here's an example of what JSunPack would output for an executable that contained these unpacked strings. And then finally, we can send these executables after we identify them to an automatic analysis environment, such as Truman, Threat Expert, Anubis, or JOBox. So the cool thing about JSunPack that it's very fast. We could run these URLs in a Honey client system and visit the URL and infect the system, and you know, that's a very costly process, especially if we want to process hundreds or thousands of URLs. So the other thing we can do with this is we can use that speed to our advantage and evaluate a bunch of different environments. So specify IE6 and IE7, and also use different JavaScript engines. The V8 JavaScript was open sourced by Google, and cscript.exe is the Windows version where you could run it through an Wine or some other emulator. So like I said earlier, the problem that the JSunPack solves is the timing issues, but it makes it so that a researcher can use an immediate proxy to decode these. And some of the problems with doing this are denial of service attacks, because we're actually running JavaScript code. We're running a JavaScript interpreter on the server, and JavaScript is a fully functional language. So you could specify loops, and often these decoding loops take 30, 40 seconds to actually work. So you know, that type of issues do exist. The cookies issue, a number of exploit sites actually set cookies, and then later on in the decoding process will access those cookies and verify that you actually entered the site through a legitimate means. So tracking those cookies, basically we need to implement a lot of the browser's functionality. And another problem with this is actually fetching the files, because the IP blacklisting could affect JSunPack. User agents can also affect it, so decoding things may require us to fetch it multiple times. Like if we wanted to decode an IE7 exploit, but we specify a user agent of IE6. So there are other challenges in this, because the browser implements a very rich document object model, and the JavaScript itself can access all of the HTML elements, replace them, do all sorts of things to make the dynamic code, make it so that HTML processing would fail. And finally, exploits for the JavaScript engine and web exploits that affect the browser. You know, these are other concerns I have with doing JavaScript decoding in this manner. So I'm going to show you another demo here. This is So I implemented JSunPack to be kind of a community portal so that you can access all of the recent decodings and recent executables that it finds so that we can share these with other people. And basically you can see all of the executables it finds and strings and all the unpacked contents of these to try and understand what the goal of these attackers really is. And the benefit of this is there's so little effort required to actually understand this after you decode it automatically. And here's an example of the most recent decodings that have been submitted to JSunPack. So really this is a researcher tool, and I think that you guys can benefit from this because there's a lot of ways to get around intrusion detection systems and really hide what you're doing, and hopefully this just gives more insight to that. So where do I think JavaScript's going in the future? I think that a lot of it will be going from one environment to the next, because a lot of these other programs, they implement JavaScript engines as well. So PDFs and Flash files can redirect to each other. So once you start having the PDFs redirect to each other and they jump between each other, it becomes very intensive to do it by hand. I mean, there's virtually no way to handle these dynamic requests by hand. I think that JSunPack is one of the best solutions out there right now. It decodes most of the exploits that you pass to it right now, and it's very easy to hook new functions and get more information out of the JavaScript engine in this way. I think that the ultimate deobfuscator, which hooks the Windows operating system, is a good solution. It requires a lot less maintenance, and it's a different solution, and I think that they both have their place in researching these malicious threats. I think a lot of the problems that JSunPack will encounter that aren't present in those systems is processing of PDFs, processing of various file types where the exploits are trying to trick the engines and the parsing. And finally, I don't think timing issues are completely solved, because there's a JavaScript function call called setTimeout, and what that does is it calls a function and has a variable timeout. And the problem there is you have to decide, am I going to hook this function and call it immediately? Am I going to wait 30 seconds or a minute? And then you get into problems of decoding taking too long, or the attacker being able to determine that you immediately requested the page and then it's going to deliver something else. So this is a big problem with all the exploit kits out there today, because they actually give you fake executables. They don't give you the real payload if you do it wrong. So to take away from this, basically you can use the website that I put up and use it to decode all of these exploits immediately. My goal with the data is to monitor all the exploits, determine if there's any new exploits, and create alerting and monitoring systems out of this. I'd also like to integrate it with intrusion detection systems, and I've considered doing a preprocessor or an output plugin that interprets the network stream and decodes the JavaScript as it goes over the network. It can cause problems, especially with intrusion detection, because of the high performance, and the unified output plugin would be beneficial because it doesn't have those requirements. It's after the fact. So it doesn't really solve the problem of blocking these, but it still allows you to detect and determine what's going on. So that I'm working on that right now and trying to put something together to release on that. So to prevent attackers from identifying JSUNPack and using that against us, I think there's a number of solutions here, and one of them is just introducing random proxy requests and comparing the results. Another would be to introduce in the cloud or large networks of traffic for sending these requests. And finally, I think a private version is necessary, so to have a public and a private face, so that the attacker wouldn't be able to identify it. I think as a solution to the JavaScript problems, NoScript is an excellent add-on to Firefox. And one of the problems with disabling JavaScript in your PDF engine is that it always creates alerts saying, are you sure you want to disable that? And every time you open a new file, it would potentially allow you to execute JavaScript if you click yes. So this is a danger to general users just because of that potential for them to execute it. And these are, last night I went through a lot of the JSUNPack data, and I wanted to show you a couple of the administrative interfaces to these toolkits. So this is probably the most widespread toolkit, El Fiesta. And in this case, we have something like 30,000 infected hosts that access this particular exploit kit on this server. So from this, we can see all of the version information tracking all of the users and the success of the exploits. So the attackers have very good insight into who's visiting their page and being able to identify where they should try to focus their attack research. And here's these are both the same kit, but this one just has different colors. This one is a Sploit 25, and a lot of these do password protect. All of these sites, the administrative interface is available on the same site as the exploits themselves. So these attackers really reuse the servers a lot. Here we can see GPack exploit system, and I believe this is a Russian exploit kit for Infector. There's a lot of unknowns in this area too. We know that these are exploit kits and they're potentially being sold, but there's no identifying information. They're all unique. And each one of these that I went through last night, they were from the past 2 weeks. So this is a very active, all of these sites are probably still up. So in conclusion, I think that really the automation of these exploit kits, the generation that they're generating random exploits and random JavaScript, and they're selling this, and basically JSunPack has to be a tool that balances the playing field and uses the automatic nature of this decoding. Are there any questions? Yes?
It's not clear from your presentation whether the JSunPack website only provides a web interface to your code, or you can download your code from your website.
So right now it is just a web interface. I would be really willing to share the code with you though.
Does the unpacking handle refers, which are frequently used as keys to unpack the JavaScript?
Yes, it does. The question was, does JSunPack handle refers? And yes, it does. Yes.
You talked a little bit about the JavaScript preprocessor for the IDS systems and the performance problems associated with that. Do you think there's any chance of a strategy rather than actually decoding the JavaScript, rather than attempting to decode, just to recognize the fact that it's been packed in a funny way?
That's one of the things that I would like to do with the data, is to collect it and identify how we're going to see this over the network. I think that's still a major problem, and like I highlighted earlier, assigning functions to variables and then translating those gives you no clear indicator. And really what we're really going to trigger on and write rules for is the widespread use of these things. So I think that JSunPack, the archiving functionality and being able to look through what's going on is a key component to that.
Thanks.
So did you find that the HTTP lib inside of Python was effective as your web browser, or did you have to write something custom in order to do the work?
I am encountering problems with it just because the HTML can get so complicated, and I've actually seen JavaScript exploits where they would put div tags around the JavaScript so that basically they're trying to assign a div ID, and then the functionality which would try and interpret that into the DOM object would fail because of that. So I think that is another challenge. Anyone else? Yes.
And then the second one was, for the portal page, have you considered something like an option to maybe not necessarily share your results, because some of the attacks are becoming targeted enough where an individual wouldn't want their information exposed?
Yeah, I definitely think that that's valuable. I'm not familiar with what ICAP is.
So like proxy servers can offload connections to analysis of like antivirus or WebSense or something like that. And
Okay.
then wait for the results of that analysis before handing the connection back to a client? It just seems like a natural fit for
Yeah,
something like that.
we share malicious code with other organizations, so I have considered that. I think. Sorry, what was your other question?
So besides the ICAP one, was
Yeah.
the question about maybe not sharing?
I definitely think
results
that
from-
a private version of JSunPack would, I would want to do that. Yep. All right. Thank you, everyone. Hey. Excellent. They're pretty good. I've been doing a lot of traveling.